Good morning, class. Our week 3 topic is all about the database models. The topic objectives for this week, the students are expected to describe data models and understand the database languages. A major purpose of a database system is to provide a user's view with an abstract view of the data. So it consists of different levels such as the physical or internal, the logical or conceptual or a global level, and the view of the external or user. The ability to modify a schema definition in one level without affecting a schema definition in the next higher level is what we call the data independence. And next we have the physical data independence. Physical data independence means it is the ability to modify the physical schema without causing application program to be rewritten. So, meaning the modifications at the physical level are occasionally necessary to improve the performance. And then we have the logical data independence. It is the ability to modify the logical schema without causing the application programs to be rewritten. So the modifications at the logical level are necessary whenever the logical structure of the database is altered. So it is more difficult to achieve than the physical data independence. So since the application programs are heavily dependent on the logical structure of the data that they access. Data model is a data-oriented technique that represents a system in terms of the system data independent of how that will process or use to produce the information. So each type of a model structures organizes and uses data differently. So it is a collection of tools for describing data and data relationship, data semantics, and data constraint. So the metadata summarizes the basic informations about the data, which can make or finding and working with a particular instances of data easier. And then we have the data relationships, which allow the relational databases to split and store data in different tables. So a relationship is the context of databases wherein it exists between two relational data models. When one table has a foreign key that references the primary key of the other table. Data semantics. It is a high-level semantic-based data description and structuring formalism, so the database model. So it is a conceptual model in which the semantic information is included. So this means that the model describes the meaning of its instances. So in other words, it is a method of structuring data in order to represent in a specific logical way in a conceptual data that includes the semantic information that adds the basic meaning to the data and the relationship that lies between them. Finally, we have the data constraints that are rules enforced on the data columns of the table. These are used to limit the type of data that can go into a table. So this ensures that the accuracy and the reliability of data is in the database. So the primary key uniquely identifies each rows or records in the database table. The object-oriented database model. In this model, the attributes and methods that operates on those attributes are encapsulated in the structure. draw its concepts of encapsulation from the software engineering idea of data abstractions and its concept of inheritance from the database idea of generalization and specialization. So it has the capability to encapsulate and support inheritance. The key concepts are the object. So if you say object, it is some of the data along with actions that can take a place on the object. So example of this is faculty. If we say class, class refers to the general structure and defines the set of shared attributes and behavior found in each object in the class. So, for example, the object is faculty. The class are faculty number, the faculty name, and the faculty address. How about the method? If we say method, this is an action defined for an object. The message is the request to execute the method, and the whole process is similar to the processing of calling a subroutine in a standard programming. So example of the method is the add, delete, change in the object faculty with the class faculty number, faculty name, and the faculty address. Inheritance, if we say inheritance, it is a new object that can automatically create by replicating some of the characteristics of one or more parents' objects. So the subclass inherits the structure of the class as well as its method. So one of the main principles of the object-oriented programming is the inheritance. So a hierarchy of classes that share a collection of attributes and methods. And it is the process where you can derive the class from another class. So the purpose of inheritance is to provide the reusability of the code so that a second class has to write only the specific features and the rest of the common properties and functionalities that can be extended from another class. Encapsulation. It means an object of data values describing the attributes and relationships of an entry. Hierarchical data model. A collection of related programs for loading, accessing, and controlling a database in which the data are organized, likely an inverted tree with a series of nodes connected by branches. So the hierarchical database model, all relationships among records are one-to-many or one-to-one, since each data element is related only to one element above. So the hierarchical model is similar to the network model in the sense that the data and relationship among data are represented by records and leagues respectively. So it differs from the network model in that the records are organized as collections of trees rather than an arbitrary graphs. So a hierarchy model describes the data in the inverted tree structures where each record has a single parent that in a sort field for maintaining order, which keeps sibling nodes in a documented way. Network database model. A database model can be represented one more complex logical relationship and used by many mainframes, the DBMS packages, so it can access the data by following the several paths because any data element or record can be related to one number of other elements. Relational database model. So the relational database model has become the most popular data models because all data elements within the database are viewed as being stored in the form of a simple tables which refer to as relations. So it organizes the data in the table format consisting the rows and columns as seen in the example. The ER model describes the data entities, the relationships. So it is a widely used for database design. The entity relationship diagram shows the relationships of entity sets stored in a database. So the database design or the ER model is usually converted to design the relational model which is used for storage and processing. So this is an example of an entity relationship model. The database languages. This includes the data definition, the data control, the data manipulation language. The data definition language is a specification notation for defining the database schemas. So it is a database management system facility which can be used to define the conceptual schema and also give some details about how to implement this schema in the physical devices used to store the data. So examples, create table account. We have the account number, character. So we have 10 and then the balance which is an integer. And then on the DDL or the database control or data control language, it generates the assets of tables stored in the data dictionary. So the data dictionary contains the metadata. So the DCL is used for granting and revoking the user access on the database. To grant access, to user grant. To revoke access from the user means revoke. And then we have the data manipulation language. It is a language that enables the user to access or manipulate data as organized by the appropriate data model. So it is a language for accessing and manipulating the data organized by the appropriate data models. It is also known as the query language. The SQL is the most widely used query language. To summarize the lecture for database models, we have the OOD or the Object-Oriented Database Model, which is a DBMS that supports the modeling and creations of data as objects. And this includes some kind of support for classes of objects and the inheritance of class, properties, methods by subclasses and their objects. While the hierarchical model, the data is organized in a tree-like structure which is one-to-many relationship between two different types of data. For example, one department can have many courses, many professors, and of course, many students. And then we have the network database model, which is a database model conceived as the flexible way of representing objects and relationship. A relational data models involves the social or use of data tables that are collect groups of elements into relations. So these models are based on the idea that each table setup will include the primary key or the identifier. And finally, we have the ER model, which is a graphical approach to database design. It is a high-level data model that defines the data elements and their relationship for a specified software systems. And then we also have the DDL, which is used to specify the database schema for creating tables, schemas, the indexes, the constraints in the database. So let us see that the operations that we can perform on the database using the DDL. So to create the database instance, use the create. To alter the structure of database, use alter. To drop the database instance, use drop. And to delete tables in the database instance, use truncate. And to rename the database instances, use rename. And to drop the objects from the database, such as tables, use drop. And to comment, use comment. Class, these are the suggested readings and references that used for week 3 class. So please find time to access those links for further studies. Thank you and good morning.